Looks like some people are finishing up. If you're done, feel free to send your quiz over towards the middle, and I'll come get it. Get myself set up here. Close enough to the middle. I'll take care of it. Very nice. I'll just use this as the key. Excellent. If you're still thinking, take your time. Don't let me rush you. Guess you think he's done? Yeah. Yeah. What's going on here? Did I? You want to circle it, or you could write it. Yeah, either one. Either one is fine. Yeah. Or you could do both. Oh no. I was thinking A B C D E. Yeah, that's fine. And you'd be surprised at how many different ways people try to answer that. I mean, you're all set? Wow, that was quick. Good job. All right, nice. Celsius? I like Kelvin myself. Oh, I suppose. Let me see. Just a minute. Now, of course, if you haven't, then I don't know which one is yours. So, here we go. I'm going to guess that one's yours. Okay. Very nice. All set? All right, great. I guess I can come to this side as well. You're all set? All right, I don't want to rush you. No, you're okay? You okay? Yeah. Okay. Right. Take your time, but hurry up. Just kidding. Okay, I guess I'll go to this side. Here. Thanks so much, Avery. Thank you. Oh, you did all right? All right, good. All right, a couple more. Oh, thank you. Pick a winner. This is it. Yep. All right, good job. Oh, I forgot. This has no staples. Look at that. That's pitiful. All right, well, I think I've got them all. I can't staple them together, so I'll just have to hope that they don't fall apart. I guess I have this envelope here. I'll just stuff them in there. There. Okay, so let's see how I did. Well, I haven't done it yet because I was setting up for something else. So let's see if I can get it right. I have 12 people in my group here. 12 people select. Think of it as a sample size. And then the P is the percentage or the probability of success. In this case, it's 7% or 0.07. And then we want exactly 2 colorblind. So that's not going to be the range. So it's either going to be, let's see, exactly 2. Looks like it's going to be letter C. And honestly, I prefer it if you actually put the letter in the blank here, but on exams, people like to circle for some reason. I guess I just did that. So I don't care, whichever way you do it, or put the number. Some people will put the number 0.1565 there. Okay, let's try this next one. 72 per 9 students. 72% are using their computer. And so more than 5 means 6, 7, 8, or 9, right? More than 5. And so it's going to be a range. And the range is going to be letter F down there, isn't it? Because you want between 6 and 9. So if you got fooled by this one, that's understandable. And don't worry, there's so many here that it's not going to be a big deal. And you'll do it right on the exam next week. That's when it matters. And then here we have 10 attempts. The number that represents P is the probability of success. In this case, we want to make the free throw or make the free throws. And so at least 7 means 7, 8, 9, or 10. And so that's this one, letter F again. No. Letter E. I almost got fooled because we want to make sure that the probability is correct. So did I get them right? Any complaints? No one's complaining. Good. All right. Several things to do that are different today. First thing, I have, let me show you our web page. I want to point something out. Um, I generally try to be, help students out because I know that that it's hard to remember things like Valentine's Day. And so I have some Valentines that I've given my wife, and I have them available to you on our webpage if you want to repurpose them. So for example, this one's pretty early. You can see I gave it to her in 2013. And I thought this was cute because it was, it's dealing with some calculus here. So anyway, I have that. And then on the inside, even though each of our limits might be 0, when I apply the squeeze theorem, double entendre, to you and me, I find that the limit of our love is unbounded. Isn't that nice? So there's that. And look, it's even got, don't tell the marketing people that I did that. Get in trouble. But so different years, I'll do something like this. So this is a number of years ago as well. But this is also, I'll show you where to find these. So if you're looking for a special card for your special friend, you might want to repurpose one of mine. So anyway, a sample of men were asked to rate the amount of love they felt for their wives on a scale of 1 to 10, and you have this box plot here. And then when you open it up, it says it turns out that I was an outlier. So there it is. So anyway, there's that. And yeah, once again, don't tell the marketing police. My wife worked for Fredericktown as a biology teacher for a number of years. And so I have several biology themed cards that I gave her. So this one, some of you know what this is. If not, all you got to do is open it up. And on the inside, you and I go together like adenine and thymine. Happy Valentine's Day. Okay, very nice. And then this one, so I guess, I forget what this thing is called. The circle. Does anyone know what that circle is called that has the AUG, whatever, like the term? This is like it's just, if you want to know what CAG, it's glutamine. CCU is proline or whatever. So anyway, it's usually presented as a circle. I don't know what it's called, but it was prominent in her teaching, I guess, at some point. So there's my thing. I turned it into a heart. And then on the inside, I love the way you fold your proteins. A little racy, I think, but still. Oh, and I changed my logo. I decided I can't use I couldn't use the MVNU logo because I kind of felt bad that I was stealing from them. Anyway, so here's one more. This one I made for colleagues. So this one doesn't have any double entendres, but still, it's kind of cool. See what great love. So this is a Bible verse on the front, 1 John 3:1. See what great love the Father has lavished on us, that we should be called children of God, and that is what we are. And so then you open it up, and it has this. Need more evidence that God loves us? He also gave us mathematics. And you have this nice heart-shaped curve here. Isn't that beautiful? And then, yeah, my logo on the back. So if you want to know where to find these amazing cards, what you can do is just go to our Moodle site and go to lots of documents and links. There's a link there that says Valentine's. And when you click that link, you'll find not only those cards, but many others from the various years. I know, no, now, just so you know, I have the doc and then the PDF. So there's duplicates here. They're not all, anyway, so if you want to change, like there's a magic trick, if you want to look at that one. So you could modify it, like if you don't like it that I say wife, you could change it to special friend or whatever it is. So equilibrium, truth table, there's a truth table one, so I didn't show you that one. There's the squeeze theorem if you really want that. There's the outlier. So if you want the outlier, that one, just change it to your boyfriend, girlfriend, whatever, and then you can make it personalized. So anyway, there they are, the proteins. Some of them, just so you know, some of these I made using a program that you can't really, you couldn't, I mean, I could modify it, but so some of these don't have the modifiable code. But there you go. So that's one of the services that I provide my students. You're welcome. So next, we're going to be doing statistics in here. Oh, yeah, so there are some other fun things. Maybe I should save that just for a minute. Yeah, let's save that for a minute because there's another fun thing, but yeah, we don't have a lot of content today. It's just fun stuff, I guess. So measures of variation. You already know about some of this, so there's just a quick review, and then we'll get to the fun thing. So the first thing is the range. Take the highest minus the lowest. that kind of gives you an idea of how spread out things are. So variation, how spread out things are. So range is just one example. How much money do you have? There might be a range of $3,000. All that means is that there's a $3,000 difference between the person with the most money and the least money. And that came from a survey that I had done a few years back. Someone said that I said, how much money do you have in your wallet? They said $3,000. I don't know if they were lying. I don't care. And then, of course, a lot of people said, I got nothing in my wallet, which is typical for people like your age, because why do you need cash when you have credit cards? Anyway, age, you might have a range of 18 years. All that means is that the biggest to the smallest is 18. So that's not something surprising. I think we might have even mentioned this. We also have, in terms of here it is, you have the variance, and the variance we've done before. So it's just a review, just to remind you, because this is going to lead into what we're going to be doing today. So the variance is another measure of how spread out you are. Maybe not as useful as the standard deviation. Standard deviation is the square root of the variance. We've already done this, so nothing new, but it just tells you how spread out people are. So if you have a large standard deviation, it means that we're all over the map. If it's small, then we're all clustered together. So what we're going to be doing with that standard deviation is we're going to use it along with what's called the normal distribution. So that's what we're doing today, is we're really focused on normal distribution. So we're shifting gears from these discrete distributions like this quiz, wherever it ended up. So this was a discrete distribution, how many people in your sample would have some trait, to continuous. Continuous is like a measurement. And you end up with usually, well, not usually, but sometimes you'll end up what looks like a normal curve. So you're probably familiar with this sort of an idea, this normal distribution, a bell-shaped curve where people are distributed, where most people are in the middle, and then as you go further away, things sort of taper off. Now there's some really interesting relationships between this curve and the standard deviation and the mean. First things first, the mean. The mean of a normal distribution is always this highest point. So that point there is the mean. Oh, I should help you just a sec, because some of you are trying to draw this. Let me go over here just for a minute, and let me show you how to draw a normal curve. It takes a little bit of practice. What you have to do is you have to think in terms of swooping up and down, and I've got something to help you sort of picture this. So, oh, that was terrible. Let me try again. Okay, that was pretty bad as well. But here, let me show you some not normal curves. So this is not a normal curve. This is not a normal curve. A normal curve looks like a hairstyle from the 1950s. So if you want to think of this, this is like a hairstyle nowadays. You know, it just goes straight down and you're all good. I don't know what kind of hairstyle this is, but here's the 1950s hairstyle. There it is. So it kind of goes out at the bottoms. Gidget. No one knows Gidget. Oh, you do. Okay. You watch the whatever, I don't know what TV channel that would be on, but I remember seeing that as a kid. So yeah, so it kind of curves out at the ends. And so there, that's pretty good. That's a pretty good normal curve. So you want it to curve up at the ends and curve sort of downward in the middle here. That reminds me of a thing that I remember from calculus. You don't have to know calculus to do this, but it's kind of an interesting fact for those of you who do know calculus. And that is that when we say that something curves upward like this, we usually use the term concave up. I don't know if anyone remembers that, concave up. And then here, this is concave down. It's kind of open downward instead of upward, concave up, concave down. The point where the curve changes from concave up to concave down is a special point. It's a point called the point of inflection. And so you'll notice right about there, you're going up, sort of concave up, getting steeper, steeper, and then you stop getting steeper and you get less steep. So that's called a point of inflection. The reason why I'm pointing this out to you is not only for the calculus people, but also to orient you. This point also has a special meaning, and that is that the standard deviation is the distance between the middle and that point. You don't need to actually, know that other than it's just a curiosity. It's kind of like this fun fact, okay? So it's a fun fact. Hopefully it's fun, maybe not. But the distance between the middle and where the curve changes from going down to going up, that's the standard deviation. Now, the reason why I'm pointing this out is because we all can figure out where we are on this curve. And we're going to do that using z-scores. But I think I'm getting ahead of myself. I certainly am. Okay, so I guess let's just put this up for just a sec. The mean is the middle for normal curves. And the standard deviation, so here's the middle, mean. Standard deviation is the distance to where the curve, changes from curving one direction to the other, this point of inflection. So, come on. So I'm going to guess it's about here for this curve. So here's the standard deviation. And you're going to have a similar point on this side. Same thing. Standard deviation is that distance, how far you are away from the middle. Okay, so let's see. We have time for this. Let's go back up and do the fun thing. So I have more statistics you can use. In keeping with Valentine's Day, I wanted to give you some, because Valentine's Day is Friday, just in case you weren't sure which day it was. I wanted to provide you with some statistics you can use with your special friend, or at least to maybe get a special friend if you don't have one. So women, so I have, this is for both of you. Both men and women can learn from these statistics. So I've got two different studies to share with you. So first off, women, when should you approach that guy you're interested in to maximize the chances of catching his eye? Anyway, all of you can guess because I'm not going to tell you the answer until the end of class. So take a guess. Do you think it's just before he enters the cafeteria, or just before he enters the chapel, or maybe just after he leaves the gym? He's all pumped up. Or maybe just after he leaves statistics class when his brain is working well. Logically, he should be attracted to you, right? Or maybe it's just before he retires to his room in the evening, like right when he's tired and it has his guard down. I don't know. You decide. When do you think? Statistically, this is an actual study that has shown this to be the case. If you want to approach a guy, when should you approach him? Guys, I have some advice for you as well. Another study separate from this one actually investigated how to dance to attract the girls. So when you're dancing, and I'll show you this at the end, which part of your body should you emphasize to best impress the ladies? So is it your butt? Should you stick it out and do that? Or is it your right knee? I don't know, like Elvis. Maybe it's your left elbow, maybe your head. I can't dance, by the way. Or is it your left foot? So which part of your body, go ahead and take a guess. And girls, you can guess as well. Try to figure out which one. And I actually have statistical evidence to back up these things, so not to worry. We'll show you that at the end. So everyone's got their guesses. You know where you're going to approach the guys if you're a girl, and guys, you know which part of the body you should emphasize when you're dancing. Okay, so before we do that, we do have just a little bit, it's a short lesson today. Going back to this typical normal curve. You can imagine where the mean and where the standard deviation are for this normal curve. But when we're comparing different normal curves, we might be interested in comparing the means and the standard deviations of two or more normal curves. And so I wanted to just show you what these look like. Here are some normal curves with the same mean. So you can see that these all are centered at this point. They all have different standard deviations. Now, if you're colorblind, I apologize. I'll try to do my best to express where I'm pointing. But the green curve at the bottom, that one is the flattest and the most spread out. That green one, so this flat spread out curve, that one is the one with the largest standard deviation because it's very spread out. Very flat, very spread. Everyone's kind of everywhere. The red curve that's poking up above the rest, that has the smallest standard deviation. Let me label these. This one is the smallest, which I know is a little bit, it feels contradictory, doesn't it? But it's the smallest standard deviation. And the reason is that if you have a small standard deviation, it pushes everyone to the middle, and that's why it's all poked up in the middle. And then the green one, the flat one, the one that it hardly even looks like a normal curve, that one has the largest. So when you think of standard deviation, when you get to this, there's actually well, I'll show you what the quiz looks like next time in just a minute, 2 slides from now. I'm going to ask you, which of the curves has the largest standard deviation? Which one has the smallest? Just pick the one that's the most spread out. Spread out means largest standard deviation. Compact, compressed, that's the smallest. So that'll help. It's kind of the reverse of what you'd think. I've got another thing to show you, and that's a bunch of curves that have the same standard deviation, but different means. This is a little easier to understand. So I've got 4 curves here, and it's pretty obvious that the average for this curve, this has the smallest mean, and this one has the largest mean. So that one's a little bit easier to kind of figure out, because you just look at the middle of the curve. This one is in the middle, and then that one's on the low end. So you can figure out comparing different means. So let me show you 3 curves. This is similar to the quiz next time. One of the questions, there's another question on the quiz. But so similar to the quiz, I want to know which one has the largest standard deviation, which one has the smallest, and then also largest mean, smallest mean. So take a minute and jot this down. So, actually arrange them from, well, yeah, essentially the same question. So arrange them from smallest to largest. So which of those 3 has the smallest mean? Which one has the largest mean? And then same thing for standard deviations. So let's go ahead and we'll find a volunteer here, and I can fix my attendance. Submit. That's it. All right, let's randomize. All right, Gracie. Gracie, which one of these has the smallest of the means? A does. Very good, because you're probably looking at this saying, hey, the mean for A is right about there. All right, so mean A is the smallest. And then which one has the biggest? Let me find another volunteer for that. Jesus, which of these has the biggest mean? It does, yeah. So C, this one, so like I said, when you're talking about the means, the averages, it's going to be pretty obvious, isn't it? You just look, where are the curves left to right? Okay, so we have, that means that B is in the middle, and then C is on the right. I guess I'll put the mean here. There. So far, so good? That wasn't too bad. Hayden, do you have a question? Oh, interesting. I didn't even label the 4th one. Interesting. Let's ignore that one since I didn't label it. I didn't even notice that. It's so funny. Okay, I guess in future, thank you for pointing that out. It's so flat and low. Yeah, you're right. This one, I don't know, where's the mean? It's right around the same place as mean B, isn't it? Yeah, let's ignore that that wine-colored curve there, the dark red. Ignore that one. Pretend it doesn't exist. Okay, so we only have A, B, and C to worry about. Oz, which of those, A, B, or C, has the smallest standard deviation? B? That's right, because it's the most compressed. So if you think of it as being which one is the least spread out, it's letter B. Very good. So sigma B is the smallest. And then we're going to find the biggest. Who's got that? Joshua does. Joshua, which one of these is the biggest? It is A. Very good. So that's going to go here. And then, of course, the middle one. It's a similar question on the quiz as well on the exam, where I just give you, I think I actually labeled all 4 of them, though. So use the ones that are labeled if I didn't label them. I haven't printed it yet, so I can always double check to see if I've done that. Very nice. So we've got that. It's pretty straightforward, isn't it? Okay. Now that we have that sort of sorted out and you understand what it means for me to show you a picture like this, let's talk about notation. So the notation that we're going to use is this. We'll say that a particular variable is approximately normal with the mean and standard deviation given in the parentheses there. So the heights of min, I think I've changed the number from before, it doesn't matter, is approximately normal with a mean of 69. That hasn't changed for some reason. I think it was 3.5 the last time we did this, but standard deviation, we'll just pretend this is a different population of men. Women, the height is approximately normal with a mean of 64. Wow, it's snowing. Oh, sorry, I shouldn't have distracted you. It's like we're getting back to winter. And a standard deviation of 3. So this just tells you the mean and standard deviation of your distribution. So let me review really quickly the z-score. So just to remind you of this, because we're going to be using it again. So test scores were approximately normal with a mean of 84 and a standard deviation of 5. And so what we would say is that, and by approximately normal, I mean that it's approximately. It means that it might not be perfect, but it's pretty close to being normal. So the mean is 84, standard deviation is 5. So I could do this and 79, something like that. So I want to know the z-score for Jimmy. So Jimmy got 93. I want to know Jimmy's z-score. So go ahead and see if you can compute that. Most of you got it right on the last exam, but a few of you didn't get it right. So take a minute, see if you can do this. Well, Dante, what did you do? Tell me the formula. What do I write down here for this thing? What's that? Okay, so let me go back one slide. Oh, it's not there. Okay, let me remind you, you're comparing the Jimmy with the rest of the class. So what's Jimmy's score? 93, very nice. What's the rest of the class? 84, very good. And so that's how far Jimmy is ahead of the rest of the class, but then we have to scale it because of the standard deviation. What was the standard deviation? 5, very good. So so this would equal 1.8, is that right, 1.8? Okay, so 1.8 mean, oh, now we get to interpret. What does the 1.8 mean? So let's see if we can get a guess. Sarah, do you have any guess? Like if you had to explain what that meant, what would you say? Wait, Siri is, I think Siri thought that I was talking to it, not you. But so what does it mean for the z-score to be 1.8? Like if you had to tell someone, like a friend, I know it's the first time, so I picked Sarah out of the blue here. Sorry. So this is, so I'll do this one. We'll come back to Sarah for the next one. So this one, it just means that Jimmy, I'll write this down. Jimmy is 1.8 standard deviations above average. So just like if you computed your z-score for your height and you found that your z-score was 1, it would mean that you're 1 standard deviation above average. Or if your z-score is -1, you'd be 1 standard deviation below average, that sort of thing. So that's all that means. And I think you'll have to do that on your homework, but I think it'll be multiple choice so that you don't have to worry as much about trying to formulate the words yourself. Sorry about pulling you out of the blue there. Blame it on the randomizer there. Okay, so there is some more fun that you're going to have with z-scores a little bit later in your homework, and it'll be questions like this. So now that you remember your z-score formula, I'll put it back up here just to make sure. You have the observation minus the mean over the standard deviation. So now that you remember that, notice the sorts of questions that you're going to have to answer. And in fact, this is too many questions, so I'm going to delete some of them while you're working on the first one. So take a minute and see if you can answer that first question. You're going to have to use some algebra. Let's do this. Oh, good. Yes. See, magically disappeared. I'll fix the others while you're doing this one. There's no sense in busy work. Okay. All right, let's see how we did. All right. So, Sarah, I promised that I would let you do the next one. So, what do you think? How am I going to solve this? All right, I like that. Start with the same. Let me plug these numbers into this same equation that you say. So 75 minus 66 over sigma is equal to 3. Is that what you mean? Okay, and then you're going to move things around? You mean by using algebra, right? Yeah. So I know it's terrifying to have to use algebra again. It was such a terrible course, wasn't it? It wasn't that bad. And actually, the algebra we're going to use is very simple algebra. Once you do a couple of these, you'll remember, oh yeah, you just move things around. So I'm going to multiply both sides by sigma, and I get this, 75 minus 66. You know 75 minus 66 is 9, so that's easy. And then you're like, well, 3 sigma is 9. That means sigma is 3. If you didn't know that, you could divide both sides by 3, and you'd get that. So there's my answer, sigma equals 3. Not too bad, right? Oh, you have to leave? Okay, go, 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 go. God be with you. You'll have to watch the video to find out how to attract that guy you're interested in. Or ask your friends. So it'll be at the end, not to worry. All right. Or email me, I can clue you in. All right, hope it goes well. Sorry. Yeah. Usually people are just offended by me and leave, but I'm glad that it's because of a baby. So actually, it's a first. I don't think I've ever had anyone rush off to give birth, or not to give birth, to assist in a birth. All right, let's do some more fun with Z. So I guess, yeah, you're off the table here, so I can't use you. But see if you can answer this one. Same deal. Let's see if we have a Z score. So here's Z is equal to X minus the mean over the standard deviation. Take a minute, see if you can figure out what X is. So I've got a secret person that I'm thinking of who has a Z score of 3. I want to know what their real score is, or their value of X. Wow. All right, Ethan, I think you're probably going to do the same thing that Sarah suggested. Is that right? You're going to do something like this? There. So what did you get for your value of X? 81. That sounds pretty good to me. Now, if you weren't as quick as Ethan, you might be saying, how in the world did you get 81? Well, do the algebra. Multiply both sides by 5. This is easy algebra. And then add 66 to both sides. So 15 plus 66 is indeed 81. Very nice. So far, so good. We can do this. It's not as hard as it looks. One more, and then we'll move on to the next topic. Suppose X equals 75 corresponds with a Z score of 3. Wait a minute, didn't we do? Oh, no, we did. This is new. I know, every possible combination of letters, right? So this is on your homework, you'll have similar questions, but it's just to make sure that you know this formula. So every time, use this formula. It's going to be so useful as we move forward after spring break especially. All right, let's see who gets to do it. Alec, I'm guessing. Oh, let me just get this started for you. That you probably started with this, just like your friends. X we know, right? Give me a sec. 75. All right. So, what did you get from you? What was that? 27. So let's see. So 27. I believe you're right. Let's just do this. So you have 3 times 16 is 75 minus the average. This requires a little bit more manipulation, but indeed you do get 27 if you do that. So 3 times 16 is 48, and then subtract 48 from 75, you get 27, and then move the mu, add mu to both sides. So this one's probably the one that requires the most algebra, but it's still not that much algebra, is it? So yeah, you should be okay, even if you're kind of weak on your algebra, I'm guessing. Not that I'm not guessing that you're weak on your algebra. I'm guessing that if you are, you're going to be fine with this. Okay, so that's the one thing. Another interesting fact about normal curves and standard deviations is that we can actually predict how much of a normal curve is within certain ranges. In fact, we'll be doing this quite a bit after well, actually next week we'll be doing this. Actually Friday. I don't know, it's either Friday or Monday. But here's the deal, is if you have a mean, so let's just use min in America, have an average of 69 inches for your height, and then the standard deviation for min in America is about 3. I keep waffling, it's a little more than 3, a little less than 3. Let's just make it exactly 3, which makes this, just a minute, this is ugly. There we go. We make this straighter. There you go. That's a little bit better. So that goes up to 72 and 3. So this is the standard. Did you see that truck go? That's probably the pregnant person. Okay, and then 3 this way is goes down to 66. So that's the standard. So let me just write this down. Mu is equal to 69. Standard deviation is 3. So what we've learned as mathematicians and statisticians is that if you do this, make a sort of a gap here, you'll notice that a large percentage of the curve is in this range. And we can predict approximately how much this is. It turns out that that is approximately 68%. 68% of all people, all men, fit between 66 and 72 inches. So if you are a guy and you're between 66 and 72 inches, you're pretty typical. You're in that middle section. In addition to that, we know, and once again, we'll see why, I guess, next week or so. Let's see, that's not a good place for that. Let's see. So 2 standard deviations. So if we go 2 standard deviations, this here is going to be 75. And down here, this will be 66 minus 3 is 62. 63. Okay, I think, is that right now? Yeah, 63. So the second thing we know, and once again, we'll show you why we know this next week, but for now, we're just going to say that this is approximately 95%. So 2 standard deviations, if you go, notice this is almost everyone, right? There's just a little bit on either side. You can imagine these are people. So there are a lot of people here. That's why this is a big bulge. And then there's not as many here, and then very few down here. And then finally, if you go 3 standard deviations, which is down here at 60 and up here at 78, that from there to there is almost everyone, 99.7%. This is called the empirical rule. So empirically, we find that when you're dealing with a normal curve, a normal population, you end up with 68% in the middle band, 95% within 2 standard deviations, and 99.7% within 3 standard deviations. So this is just in general. Empirically, this is what we find. In reality, these don't copy these numbers together. Don't do that. We'll be doing this next week. It's just 68, 95, 99.7. Those are the numbers that matter for this. And we're in good shape. I just want to make sure we leave enough time to show you the answer to those 2 very important questions to help you out, because Friday's coming. Okay, so how are we going to use this? Well, let's say that we have this situation. We know that IQ scores, and this is certain IQ tests are scaled differently than others, but most of them are going to be, so you psychologists can correct me if I'm wrong, but most IQ scores are scaled so that the mean is 100 and the standard deviation is about 15. So let me go over here so I can paste this in here because I need to also get a normal curve. Hold on a sec. So one more thing, grab this, go back, grab my normal curve. Where is it? There it is. And I'm going to just get rid of all that ink. Okay. I just like to have a nice normal curve to work with. And there. So what we're going to do is we're going to use the empirical rule to approximate the answers to these questions. So here's our typical normal curve. I'll just put it down here. Let me zoom in. I'll zoom back out when I need to. So IQ scores, mean is 100. Standard deviation is going to be 15, which means that goes up to 115, 130, and 145. Down here, we go down to 85, 70, and 55. So these are IQ scores, approximately normal. This is the way that IQ scores are computed, is they try to norm this. So first off, I want to know the proportion or the percentage of IQ scores between 70 and 130. Well, let's look at my little diagram here. Between 70 and 130 is this stuff. That stuff corresponds with 2 standard deviations on either side of the middle. And so that will be 95%. So not too bad. Let's see, can I do this? Hold on a sec. Copy. Way I can paste. Oh yeah, that's good. So there's 95%. Let me just erase the red stuff so that I can restart with the next question. So that's part A. Part B, second one. What IQ scores are between 115 and 145? So for this one, 115 to 145 is a little bit more complicated. So to do this, I'm going to have to sort of, I don't know, do a little bit of algebra of sorts. So here's how I'm going to do this. I'm going to piece this together using some logic or whatever. So let's go 1 standard deviation on either side is 68%, which means that these two together are going to be 32%, which means that this thing, if we include everyone, including all the geniuses, that whole wedge there is 16%. However, I need to get rid of the geniuses because I only want to go up to 145. So I only want this section. So I need to sort of restart, I guess. Let me paste this back in here. Just a sec. So you can see that this is kind of like a puzzle. This is probably why I like it so much. If we go between 55 and 145, you get 99.7. That leaves for all the geniuses and the people who are low IQs, that's 0.3%. So that means that the people up here is half of them, 0.15%. I know this is dizzying, isn't it? So 15%. And so subtract those, and you'll have this portion is 15.85%. Wow, that took a lot of effort. Hopefully that won't be like on your homework. Let's just do this next one. The next two are much easier. That one was hard. That was too hard. I'm sad. Okay, so let's do this one. More than 130 and then less than 115. Those are easier. So let me erase some of this. We'll do more than 130. So give me a sec here. There. Okay, so more than 130. So 130 is here, 70 is there, that's 95%, right? And so what we know is that 95% of everyone is in that range, which means 5% belong outside that range. So if you combine the people that are above 130 with the people who are below 70, together they make 5%, which means that if you split them up, because those are about the same size, each one of these will be 2.5%. 2.5%. All right, I should have made you do one of these. So why don't you do the last one? The last one is, what percentage of people are less than 115? Let me just get it set up for you down here, and then you can go to it. So less than 115, hold on a minute. There. Okay, less than 115 would correspond with this, from here all the way over there. So all of these people. So what percentage are less than 115? Take a minute, see if you can work it out, and we'll pick a couple of volunteers to help me out. And then I promise I'll give you the answers to the questions at the beginning. All right, Sienna, I know you just finished drawing this curve, so you probably don't have the answer, but I'll bet you can get me closer to the answer. Are there any numbers that I could use to get my answer that you can think of that would be related to this picture? Here, let me show you what I mean by what numbers am I asking about is these. Do any of these numbers correspond with the picture that I have drawn here? It's not going to be perfect, but which one do you think you're going to use? The 90, the 95? You could use the 95, yeah. How about, are there any other numbers you'd like to use? Yeah, pick another one. You're up. Okay, just name one of these numbers right here that you can see on the screen. You could use that, but let's look at this big number up here. 68. Yes, you're right. 68%. Very good. So let's see how that fits into the picture here. Thank you so much. So let's go ahead and put that on. So 68%, as Sienna figured out, is the percentage in the middle here. So that is 68%, right? So that band, that middle band is 68%. We still have to deal with that chunk over there, but don't worry, we're going to do that. So let's see if we can figure out that chunk that we're missing. So we've dealt with the middle chunk. We need to figure out this piece. To figure out that piece, notice that those together are kind of, grouped together would be related to 68. Caleb, do you know how those are going to relate to the 68? Yeah, 95 doesn't play into this particular problem because 95 would be between 70 and 130. Yeah, this is everyone else, including the super smart people and the other people. That's it. Yeah, so 100 minus 68. So you got 68 in the middle. 100 minus 68 is everyone outside of that band. So yeah, maybe I should have written that before. So there it is. So this is 32%. Very good. And that includes people that are way over on the left and people way over on the right. So I just want the people on the left here. So Kirsten, do you know how to just isolate those people? Yeah, so we've got, so this 32 is both of these little wedges. I just want that one. So divide by 2 and you get 16%. And then my final answer is 68% plus 16%, which is 84%. Wow. Well, hopefully that won't throw you too much. So let's get the answers to those two questions that we had. Number one, where should you approach that guy if you're interested in, that you're interested in? So this is according to, this is the Hungry Man survey that may give it away, but this is according to this in the British Journal of Psychology. It's about 20 years old, but still it holds up well. Does hunger influence judgments of female physical attractiveness? Now check it out. What these people did, it's going to seem kind of sketchy, but they sampled 30 hungry guys on the way into the cafeteria and 30 satiated guys. These are people coming out of the cafeteria. They asked them, how hungry are you? And they separated them into groups. And each participant was shown 50 photographs of women in tight gray leotards and tights with their heads obscured. I realize that this is problematic, but it still is fascinating. So here is the graph that they produced. And this is the average attractiveness rating that these guys gave these women these images. So the dark circles or the dark squares are the satiated guys, the guys that were full, and the open circles are the hungry guys. And they even, like each individual picture, they have the BMI. I'll let you figure out what that all means. But you can see that in almost every case, hungry guys think you're more attractive than non-hungry guys. And the effect seems to be greater for certain body types. Now, what about the guys? What should you do? Well, the Dancing Man study, what they did is they did something just as kind of problematic maybe. And they put guys in tight suits that have like computer, I don't know, like sensors on them and had them dance to music. And they showed these dancing images to women. I have 2 videos to show you in just a minute. But here's the conclusion. So guys, linear regression subsequently revealed that 3 movement measures were key predictors of dance quality. These were variability and amplitude of movements of the neck, the trunk, and the speed and movements of the right knee. So not the left knee, right knee. Do it like Elvis. Let me show you, because this is amazing. So I have here the images. This is what they showed these women. And no music. They just showed them these images. So this is the worst rated dance person. So this is the very lowest rated one. And you can see how, this is the way I dance, by the way. And then let me just a sec here. Is it all done? Yeah. Okay, it's pitiful, isn't it? Okay, yeah, and then here's the best. There it is. I know! And look at that right knee. I'm telling you. So good. Okay. So guys, this is what you want to do on Friday.